Assalamualaikum, very good afternoon to everyone. So I hope everyone is in a very ping of health, alright, still safe at home. So hari ini I will proceed further with the presentation of lecture untuk chapter 4, topic fluid static. So basically for this chapter presentation, the lecture I will divide it into 3 important sections. 4.1, 4.2 and 4.3. Alright, so now have a look at to the chapter 4, fluid static. Basically in fluid mechanics, kita ada two important discipline. First, fluid static, and the second one is fluid dynamics. Kalau fluid static adalah kajian fluid mekanik yang melibatkan ataupun involving the condition when fluid at rest. Bila mana cecair ataupun gas, when we talk about fluid, sama ada fluid in the form of liquid or gases, so they are in the situation at rest, tidak bergerak, pegun ataupun no movement. Tapi kalau the other part covered by Mr. Fairuz, fluid dynamic adalah kajian fluid mekanik when involving the fluid at moving or in moving condition. Alright, and then kita akan proceed further with the next slide on objective. Okay, now we move on to the next slide on objective. Alright, so for the first objective, I will give a very brief introduction about the fluid static. So at the end of my lecture, I'm hoping that my student able to differentiate between the fluid static and fluid dynamic. So basically, fluid static is any study related with distribution of force, load and pressure to fluid when the fluid is at rest condition. However, at the other side, the fluid dynamic is study when the fluid is at the moving condition. Alright, and then the second one, in fluid static analysis, it always involves two main important attribute. First attribute is on the hydrostatic force. Sebab bila ada banyak daya yang bertindak, akan ada satu daya membentuk daya paduan. Dan daya paduan pada analisis fluid static kita namakan sebagai hydrostatic force. And then the second important attributes in fluid static analysis is center of pressure, di mana daya paduan tersebut akan bertindak balas pada permukaan yang bersentuhan dengan bendalih tersebut. Jadi basically, to make it your view about this fluid static becoming clear, so normally when we imagine the fluid, okay, if let's say this is a fluid, okay, when we give the shear force, daya Richet, shear force is daya Richet at the tangential direction, okay, with the very minimal force to the fluid, it will allow to, the fluid to flow. Alright, this is not happen when we talk about the fluid static. In fluid static, the force are given at the perpendicular normal condition. Maksudnya 90 degree kepada bendalih, arah bendalih tersebut. And then fluid static normally kita boleh imagine, contoh kita ambil satu empangan, the water dam. Okay, this is water, ada free surface, right? And then ini adalah the water dam. The water dam. Okay, when the water inside the water dam is in static condition, alright, this condition we call them as a fluid static condition. Other example is when water contained at lake, inside the lake. And then for easy example is when water contained at the tank. It establish condition of where fluid static condition is compliant. Alright, Okay, first of all, I want to introduce on the fluid static again. So fluid static basically deal with the problem associated when the fluid at rest. Maksudnya apabila fluid sama ada gas or liquid berada dalam keadaan pegun, tidak bergerak, no moving at all, at static condition. So in fluid static, if we deal with the water or liquid base, we call them as hydrostatic when the fluid is in liquid form. But when the fluid is in gaseous form, we study on the aerostatic. So again, I would like to emphasize in fluid static, there are no relative motion at between adjacent layer, as we understand that fluid are formed from layer by layer. So when there is no shear force that acted on the fluid tangentially at their direction, in their direction, so there is no force for them to deform it. So the only stress that we deal in fluid mechanics when we talk about the fluid static is normal stress. Fluid at the perpendicular direction, berserenjang dengan arah bendalih tersebut. And then the variation of pressure basically due only because of the weight of the fluid. And then the topic of fluid static only apply when we consider and significant when gravity acceleration involved, or when it involving the gravity field. So the design of many engineering application considering the fluid static understanding is like the water dam, the liquid storage tank that require determination of the forces acting on the surface of using the fluid static. So sebab apa fluid static ini penting? Kalaulah kita tentukan the maximum force that the structure able to hold salah, so our structure tu, say for example the fluid dam water valve mungkin akan pecah during their operation. Okay, as we all know and understand, fluid sama ada bendalih cecair ataupun bendalih gas mempunyai berat. Contoh kalau kita isi air dalam baldi. Okay, ini baldi kita kat rumah. Kita tadah air. Alright, baldi itu berat. So it having weight. And then ia pada keadaan gravity dia akan menghasilkan daya. Alright, sebab daya ni datang daripada the multiplication product of between weight and gravity. Alright, so tekanan bendalih, so the fluid pressure basically adalah disebabkan oleh daya-daya yang bertindak pada bahagian permukaan yang bersentuhan dengan bendalih, because the fluid introduce the weight onto the surface of the object. Okay, say for example, kalau kita ada satu keadaan objek submerged, tekanan akan bertindak pada keseluruhan permukaan yang bersentuhan dengan bendalih tersebut, dan setiap komponen tekanan ini adalah datang daripada daya-daya kecil. And then the summation ataupun total daya tersebut, komponen daya akan menghasilkan daya paduan F. Dan dalam kajian fluid static, daya F ini dinamakan sebagai Fr, kita namakan sebagai daya hidrostatik. Okey, jadi in fluid static discussion, there are two important case. Okay, case 1 dan case 2. Case 1 apabila objek berbentuk rectangular submerged in perfect horizontal, mendatar, alright ya. Dan case 2 adalah bila objek berada dalam keadaan submerged in the form of inclination condition. Dia incline, condong. Bagi analisis daya yang melibatkan kes 1 ini adalah agak mudah sebab pressure adalah sama pada semua titik sepanjang objek tersebut. Alright? Sebab apa? Sebab P equals with rho GH. Dia mempunyai ataupun berkongsi depth yang sama pada semua bahagian. Tetapi bagi kes yang kedua, if let's say ini titik A dan ini titik B, alright? Pressure at A and pressure at B adalah tidak sama di antara satu sama lain. Normally pressure at B is higher compared than A. This is because of perbezaan pada depth. Alright, so dekat sini rho GH1 dan dekat sini rho GH2, yang mana H2 adalah lebih besar daripada H1. So pressure at B point is normally higher compared than A in theory. Alright, and then the most important dalam analisis fluid static, kita sentiasa melihat di mana center of pressure dan juga di mana hydrostatic force tu akan bertumpu. Bagi kes satu, analisis adalah mudah sebab bagi satu blok rectangular, titik di tengah ini sentiasa kita akan refer sebagai C, which is centroid. Alright. Saya lukis balik okay, the hydrostatic force normally akan acted onto the centroid. Okay, so this is Fr, and then centroid sentiasa akan menjadi center of pressure, titik tekanan bagi kes yang mendatang. Jadi analisis daya yang melibatkan kes yang mendatang agak mudah untuk kita dapat ataupun kirakan the F and also P. Tetapi bagi kes yang kedua, disebabkan oleh perbezaan tekanan di antara titik yang disebabkan oleh perbezaan H, nilai depth, okay, the Fr, okay, let's say this is the centroid, centroid is no longer acted on the centroid point. Okay, Fr akan teranjak sedikit, akan membentuk tindak balas reacted on a new point. We call them as the new established center of pressure untuk kes yang mendatang. Jadi dalam fluid static, untuk kuliah 4.1 ini, saya akan cuba terbitkan persamaan untuk anda semua faham dengan lebih lanjut how to derive the equation for Fr as our first objective, and then the second is how to derive the equation to calculate for the center of pressure. Slide, alright. Hydrostatic force on the submerged plane surface, maksudnya pada permukaan satah yang tenggelam. Contoh pintu air di perempangan air lah the wall of liquid storage, dinding bagi satu tank ataupun permukaan kapal yang berada dalam keadaan rehat is basically subjected to fluid pressure when it distributed over its surface when it exposed to the liquid. Maksudnya permukaan yang mana-mana bersentuhan dengan fluid, dekat situ pressure akan acted onto the surface, introducing the pressure. Alright. On a plane surface, the hydrostatic force form a system of parallel forces. Parallel forces tu adalah daya yang bertindak normal ke atas permukaan. And then kita selalunya memang akan diperlukan untuk menentukan magnitude bagi daya tersebut. And then the application, the point of application, we call them as the center of pressure. Maksudnya, center of pressure is the point where the forces, the resultant forces intersected at that point, right? And then the hydrostatic force and also the center of pressure, kita boleh kira menggunakan dua rumus yang ini. Tapi we don't know what is A. Kita tahu A itu area, tapi nak ambil area yang mana kan, H tu apa dan sebagainya. So why not we look at to our next slide ataupun next discussion on how to derive the Fr, specifically the hydrostatic force, and also the Yp here. Yp is not Ep, but Yp is the center of pressure where the hydrostatic force is intersected perpendicular or normal at the surface. Alright. Now we start back for derivation of Fr, the hydrostatic force, and also the center of pressure untuk case 2. So basically in our fluid static analysis, we are more interested on the analysis of case 2. Bila flat surface position at the inclined position. And then when dia position at the incline, keadaan condong, dia akan membentuk satu sudut theta. Untuk analisis kita kena buat satu gambar rajah yang kompleks macam ini. Nampak macam sukar tapi sebenarnya taklah susah sangat. Okay, ya. So kita cuba define one by one. So ini adalah free surface, yang macam inilah. Dan bila satu flat surface tenggelam membentuk sudut theta, dia akan menghasilkan what we call that, daripada free surface kepada centroid adalah jarak h bar. Alright? And then kita kena maklum juga, kita ambil satu titik rujukan kosong di sini, ini merujuk kepada paksi OX. Alright, jarak daripada paksi OX, which is your y bar, adalah merujuk kepada jarak centroid daripada paksi OX. And then we understand that bila satu flat surface berada dalam keadaan yang incline, dia akan menghasilkan satu daya paduan pada center of pressure yang baru. Ini daya paduan yang kita akan buktikan sebentar lagi, the equation. And then this is the center of pressure. Dan center of pressure, when we refer to this axis of reference, which is OX kita tadi, ia adalah y bar. Jadi dekat sini kita akan tentukan the FR dan juga CP, yang mana FR ini yang ini dan CP adalah Y prime, ya. Okey. Jadi to derive the equation, okey, kita mengambil satu elemen. Kita panggil dia sebagai elemen area. Okay, and then one element with delta A mempunyai keluasan delta A submerged from free surface daripada jarak free surface dengan distance banyak h, ya. Alright, we understand that P adalah sama dengan rho GH. Ini adalah basic equation yang kita akan sentiasa refer, and then we also understand that P sama dengan F over A. Jadi bagi case untuk yang small area element, dia akan jadi delta F bahagi dengan delta A. So delta F sama dengan P delta A. Alright. As we understand that P yang ini adalah sama dengan rho GH, so kita gantikan the P here kepada delta F sama dengan rho GH delta A. Alright. And then by referring to this equation, okay, kalau kita boleh mudahkan keadaan di situ, kita dapati bahawa ada satu trigonometric condition here. If let's say ini adalah H dan if let's say ini adalah Y dan ini adalah sudut theta, alright, so sin theta sama dengan H over Y. Jadi untuk H yang di sini kita boleh kemas kini atau modify the equation of sin kepada Y sin theta. Same goes to the condition when at the centroid. Okay, now we dealing with H bar and Y bar. So sin theta sama H bar over Y bar. So H bar equals with sin Y bar sin theta, ya. Jadi masukkan ke dalam persamaan yang ini. Alright. So what we have now is delta F equals with rho G Y sin theta delta A, yeah. And then by looking at to this equation, alright, we rewrite into rho G sin theta integration of Y delta A, this part becoming F. So basically this part we call them as first moment area. First moment of area. Okay, yang mana first moment of area adalah y delta A sama dengan A y bar. Okay, so by having this, we change to this equation. Now we find that our equation becoming F equals with rho G sin theta A y bar. Okay, now further modify F equals with rho G y bar sin theta. Okay, and then multiply with A, and then we found that here similar with this, the H bar, and then at the end the F becoming rho G H bar A, and then this F is becoming our Fr, which is the hydrostatic force. Yang mana the H here is the centroid distance from the free surface. Here, centroid distance from the free surface from here to here, and then the F now becoming Fr is hydrostatic pressure. So, bila nanti keluar soalan untuk kamu diminta kirakan Fr, what you need to do is you need to find the H bar. What is the distance from the centroid to the free surface, and then you also need to calculate the area, and then by simple or as simple as multiply it with the gravitational acceleration G, normally 9.81 meter per second, and also the density of the fluid, normally water is 1000 kilogram per meter cube, and then as simple as that, you now can determine your hydrostatic force. Okay, again to refresh, now after we understand on how to derive the Fr, the hydrostatic force, apa pula yang dimaksudkan dengan CP? CP is the center of pressure, whereby the point where the force is perpendicular or normally intersected. Alright, dekat sini the Fr, and then CP is located at here. So basically CP will be located further down than C. C is the centroid. Centroid adalah titik tengah. Jadi always remember that. Okay. So before we proceed further to derive for our CP ataupun Y prime adalah jarak daripada OX, part COX tadi. Okay. We need to remember these two equation. Okay. Satu, F sama dengan rho G sin theta. The integration of y delta A. This is our first moment of area, and then rho G sin theta A y bar here. Ingat y bar tu yang mana? Y bar adalah jarak OX kepada titik centroid, ya. The y bar here, and then the hydrostatic force is rho G H bar A. This is our main first important equation. Okay, to start, we need to understand that when summation of F sama dengan F, which is our resultant hydrostatic force, okay, for or at all element, it also will similar for the summation of moment at particular axis, will always equal with the moment at any axis. Moment ni bukan moment keriangan, tapi moment is basically adalah M is the product of multiplication between F dengan Y. Y is our distance and F is our force. Okay, by having this kind of understanding, when the F, the hydrostatic force, as we determined just now, multiply with the Y prime, Okay, we get the f times y equals with the rho g sine theta integration of y delta a, alright, times y. Okay, this comes from here. Okay, and then this multiply with the y, the distance. Okay, and then we modify the equation becoming integration a rho y rho g rho g y squared. The y here multiply with y darabkan. Okay, sin theta, kami run sin theta delta a. Okay, at the end we will have the rho g sin theta a y squared dA. And then by dividing the f here with this right part, okay, kita dapat the y prime here, our CP now becoming rho g sin theta integration a y squared dA with f, our equation now becoming y prime rho g sin theta integration a y squared dA divide by f tadi, yang ini sama dengan rho g sin theta y prime y bar a. Mana dapat yang ini? Yang ini adalah daripada sini. Okay, right? So what happened to this equation when this eliminate by this? Okay, now we get y prime equals with integration of a y squared dA divide by a y bar. Okay, so by looking at to this equation, we understand that this integration of y squared dA is referring to the second moment area divide with first moment area. And then second moment area also can be written as AK squared OX. Looking at to this axis, part C yang ini, okay, bahagi dengan A y bar. So take it this equation as our first equation. Okay, simpan dulu equation yang ini. Alright. So before we proceed further, we need to understand that our CP, the center of pressure, the y prime here, must be always positive and located further down compared than the centroid, the C here. And then the CP, the here, the center of pressure, and then the C, the centroid here, will be overlapped only when the flat surface is positioned horizontally. Maksudnya mendatar, bukan in inclined condition. So by having that kind of understanding, we can apply the parallel axiom theory. Parallel axis theory, axis theorem. Parallel axis theorem ni theorem part C berselari. Nak lebih faham kena tanya mathematics lecturer. Okay, we found that from the parallel axis theorem, the AK squared OX ni, yang ini AK squared OX adalah sama dengan AK squared OX plus AY square, AY bar squared. Okay, or can be written as well as the IOX equals with ICC plus AY bar squared. Okay, so what is basically the ICC? The ICC can be referred direct to the slide. Okay, if you Google from the internet to find out the moment inertia for certain shape, will be different. If rectangular, A, B kuasa 3 bahagi 12, that one is ICC for the rectangular shape. But for the circle shape, the ICC becoming pi R kuasa 4 bahagi 4. It's different. So different kind of question. If let's say your flat surface in the form of circle, apply the ICC using this equation. It always be given during the examination. Okay. This equation, have looked at to this equation back. We label them as equation number 2. Okay. Now, by substituting the equation number 2 into equation number 1, okay, equation 1 here, alright, we found that the y prime equals with ak squared ox divided by ay prime, okay, can be written as well as ICC plus ay bar squared divided by ay bar. Alright, so then you will have the iox over ay prime, the y prime, y bar here, equals with ICC plus ay bar squared over ay bar. Okay. The y prime here, okay, remember, is our CP, the center of pressure. The ICC, as I said just now, is the moment of inertia, second moment of area, and then y bar is the distance from the OX axis here to the centroid, okay, the y bar here, and then final equation for CP is basically becoming y prime equals with ICC over a y bar plus y bar, okay, whereby this is eliminated out. So as simple as dealing with the fluid static question, first question normally they will ask you to calculate for Fr. So Fr, the hydrostatic force, as simple as by using the equation here, rho g h bar A. Rho is fluid density, g is gravitational acceleration, h bar is the distance from the free surface to the centroid, okay, and then A is the area here, and then the question will ask you to calculate for the center of pressure y prime or CP. As simple as you need to determine the second moment of area first, the ICC, divided by the area times the y bar. The y bar is basically the distance from the OX into the center, the centroid, titik tengah bagi flat surface, plus with the y bar itself. So please remember these two equations, and then you will survive by understanding the derivation of both equations. I'm hoping that all of you will appreciate the mathematics behind the fluid mechanics, and then you will further understand the theory. Thank you.